Today, my topic is about the formation of our solar system.
Billion years ago, a peaceful cloud of gas and dust collapsed into a single central star, and the leftover dust quietly clumped together to form the surrounding planets. Curious. But this clean narrative ignores the unbreakable first law of thermodynamics. Matter and energy cannot be destroyed, they only transform. If the universe operates as an endless engine, why assume our local neighborhood was born in a linear event? A speculative framework called the multi-star hypothesis asks us to look at our planetary history differently. It suggests that our early solar system was highly volatile, a warring structure containing multiple stellar bodies fighting for gravitational dominance. The quiet sequence of orbits we see right now is not a finished product. It is the cooled graveyard of a violent multi-star system. To see how that multi-star system operated, we have to rewind to a time before our sun existed. By then, the Milky Way had already been spinning for billions of years. Ancient, massive star explosions seeded our region of space with heavy elements and chaotic energy long before our local dust cloud began coalescing. When that local gas cloud finally collapsed under its own weight, gravity did not simply funnel all the available material into one neat central core. Instead, enormous explosions of matter and energy tore through the forming nebula, causing massive, localized fragmentation. From those glowing fragments emerged the early versions of the bodies we now call Jupiter, Saturn, and a massive, mysterious object known as Theia. In their youth, these objects behaved like proto-stars. They had enough mass to generate extreme internal heat and emit tremendous energy, even if they lacked the bulk to ignite into fully stable stars. This graph shows the early solar system's thermodynamic reality. Over millions of years, smaller proto-stars bled energy, weakening internally as the central sun grew stronger. Plunging temperatures cost them their gravitational independence. The sun overpowered them, locking these fading bodies into rigid orbits. The gas giants circling us today are essentially demoted, burnt-out stars, trapped by an overwhelming gravitational force. This capture process was highly unstable. Forcing massive former stars into submissive orbits created severe gravitational friction, causing violent disruptions across the entire system. Jupiter acted as the primary disruptor. Because it retained an enormous amount of mass from its proto-stellar phase, its gravity dominated the outer system and shoved surrounding material severely off course. This friction was accelerated by the physical reality of differential cooling. A smaller celestial mass will bleed off its heat exponentially faster than a massive one. The smaller, unstable body known as Theia lost its energy rapidly, was thrown off its orbital path, and slammed directly into the proto-Earth. This single impact vaporized enormous chunks of both worlds. The resulting cloud of superheated rock eventually condensed and cooled into the Earth we occupy today, along with our moon. Leftover shrapnel from this deep space collision, and others like it, scattered inward to seed the rocky material of Mercury and Mars. The intense violence of these planetary impacts is the direct physical consequence of a chaotic multi-star environment collapsing into gravitational order. From our current vantage point, the solar system appears perfectly stable, ticking along like a permanent, reliable clock. But when we zoom out to the galactic scale, the math shifts. The stability we experience is highly likely to be a temporary resting phase. Over billions of years, all matter, even the most rigidly structured star systems, will eventually degrade and drift toward extreme gravitational collapse. At the center of that collapse are black holes. Rather than functioning as absolute destroyers that erase matter forever, the physics suggest they act as cosmic recycling centers, compressing material into the raw seeds of new universes. This brings us directly back to the first law of thermodynamics. Everything reverts to energy, never destroyed, only transforming. Under this model, space and time do not travel along a straight line. They operate as an endless, repeating cycle of destruction and rebirth. The seemingly permanent configuration of planets we call home is simply a fleeting transitional chapter in an eternal cosmic loop.